Hello grade 10 students, welcome back. This is video lesson number 12 and I am Madhu Vatke. We are in last section of chapter 2, polynomials. In previous video class we learnt about division algorithm for polynomials. Today we will learn how to apply division algorithm and some other concepts that we have studied in the chapter to find all zeros of a polynomial when some of its zeros are given. All concepts and questions done in the video class are to be written neatly in your notebook. To understand the process of finding all zeros when some of the zeros are given, let us consider this problem. Find all zeros of the given polynomial in x if two of its zeros are 2 and minus 2. Now the degree of the polynomial is 4 and two zeros are known. That means you need to find two more zeros because in all it will have 4 zeros. In our previous video class, we have studied that if we know the zeros, if alpha and beta are zeros of a polynomial p of x, then x minus alpha and x minus beta are factors of p of x. So we use the same concept over here. 2 and minus 2 are the zeros. So this implies that x minus 2 and x minus 2 are factors of p of x. So this implies the product of these two factors will also be a factor. So x minus 2 into x plus 2 is also a factor of p of x. So we multiply these two brackets, a minus b, a plus b will give us a square minus b square. So x square minus 2 square will give us 4 is a factor of p of x. Now if x square minus 4 is a factor of this polynomial, then on dividing the remainder should be 0 and the quotient will be the other factor. Let's take simple numbers to understand this. 3 is a factor of 15. So we divide 3 by 15, so the remainder will be 0 and the quotient is 5 and quotient 5 is also factor of 15. So 3 and 5 are the factors of 15. The same logic we use over here. So we will find out the other factor by dividing the given polynomial by x square minus 4. So we use the long division method. X to the power 4 plus x cube minus 34 x square minus 4x plus 120 divided by x square minus 4. To find the terms of the quotient, we will follow a step-by-step procedure that we had learnt in the previous video class. Now solve in your rough columns. Divide the first term of the dividend by the first term of the divisor. We get x square, that is the first term of the quotient. Now multiply x square with every term of the divisor. We get x to the power 4 minus 4x square. So that will come under the x square term. Subtract. So we change the sign. Carry down the terms. X cube. Here I will get plus 4 minus 34, that is minus 30 x square minus 4x plus 120. Now to find the second term of the quotient, we divide x cube, the highest power term, by the highest power term of the divisor. So we get plus x as the second term, multiply plus x with every term of the divisor. We get x cube minus 4x. Subtract, so we change the sign. So minus 30x square plus 4x and minus 4x is 0 plus 120. These two terms are carried down. Now we find the third term. So to do that, we divide minus 30x square by x square. So we get minus 30 as the third term. Multiplying minus 30 with each term of the divisor, we get minus 30x square plus 120. On subtracting, we get 0 as the remainder. So here, if we do not get 0, then it is understood that we have made an error in the long division process, because we know that x square minus 4 is a factor, and therefore we have to get a 0 over here. In case we don't get, then you have to go back and recheck your long division. So now the quotient is x square plus x minus 30. So this is the other factor that we are talking about, but yet it is not completely factorized. You can factorize it further. This we will do by splitting the middle term. So for this quadratic polynomial, let us find the product. Product is the multiplication of coefficient of x square and the constant, so we get 30. Now split 30 so that we get the sum of those two factors as the coefficient of x. So if we place plus with 6 and minus with 5, then minus 5 and plus 6 add up to give you plus 1 and multiply to give you minus 30. So these are our factors. Now I can write directly these factors as x minus 5 into x plus 6. This can be done only when the coefficient of x square in the quadratic polynomial is 1. When a is equal to 1, then only this method is applicable, where you can write the factors directly. Only then. Otherwise you have to follow the process of splitting and then finding common. So we have factorized the quotient polynomial further. So now equating the quotient polynomial to 0, we get x minus 5 equal to 0 or x minus 6 equal to 0. So solving this, we get x equal to 5 and x equal to minus 6. So we have got the other zeros also. So the zeros are 2, minus 2, 5 and minus 6. So we have obtained all four zeros. Question 2. Obtain all other zeros of p of x if two of its zeros are root 5 on 3 and minus root 5 on 3. In this question, the zeros are irrational numbers. We will apply the same method in order to get the other zeros like we did in the earlier example. So if alpha and beta are the roots, of the polynomial, then x minus alpha and x minus beta are factors. So since we have alpha and beta, we will write down the factors of this polynomial. So this implies x minus root 5 on 3 and x minus root 5 on 3 are factors of p of x. This is x minus root 5 on 3 into x plus root 5 on 3. The product of these two factors will also be the factor of p of x. So x minus root 5 on 3 into x plus root 5 on 3 is a factor of p of x. Now this is same as a minus b into a plus b. So this is equal to x square minus root 5 on 3 square. This can be written as x square minus 5 on 3. On multiplying this polynomial by 3, we get 3 times x square minus 5. So 3x square minus 5 is a factor of p of x. Since it is a factor of p of x, when we divide p of x by 3x square minus 5, the remainder should be 0, and that is how we will get the other factor. So let's use the long division process. The dividend polynomial is already arranged in descending order of the power of the variable, and the divisor is also in the descending order of the power of the variable. So let's start finding the quotient terms. To get the first term of the quotient, we divide the first term of the dividend by the first term of the divisor. That is 3x to the power 4 divided by 3x square. We get x square. So x square is the first term of the quotient. Now multiplying x square with every term of the divisor, we get 3x to the power 4 minus 5x square. So it will be written under the like term minus 2x square. Now changing the sign. So 3x to the power 4 minus 3x to the power 4 gives us 0. Carry down the remaining terms. Subtract the x square terms. We get plus 3x square minus 10x minus 5. Now we will find the second term of the quotient. To do that, we divide the first term of the remainder, that is 6x cubed, by the first term of the divisor, 3x square. So we get 2x. So plus 2x is the second term of the quotient. Multiply 2x with every term of the divisor and write down. So we get 6x cubed minus 10x. To find the difference, change the sign of the second expression. So these two terms get cancelled. Carry down the remaining terms. 3x square minus 5. Now the degree of the remainder is 2 and the degree of the divisor is 2. So we can find the third term. Divide the first term of the remainder polynomial by the first term of the divisor. So we get the third term of the quotient, that is plus 1. Now multiply plus 1 to the divisor. We get 3x square minus 5. On subtracting, the remainder is 0. So now we have got the quotient polynomial as x square plus 2x plus 1, which is a factor of p of x. We can further factorize this polynomial using the identity a plus b the whole square. So this will be x plus 1 whole square, which is equal to x plus 1 into x plus 1. So equating this polynomial to 0 to find the remaining 0. So x plus 1 equal to 0 or x plus 1 equal to 0. So x is equal to minus 1 and minus 1. So the zeros are root 5 on 3 minus root 5 on 3 minus 1 and minus 1. Question number 3 is another type of problem based on division algorithm. On dividing the given polynomial by g of x, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. So here in this question we have to find the divisor. So we use the division algorithm. Let's write down first the quotient polynomial is x minus 2. Remainder polynomial is minus 2x plus 4. Writing down the division algorithm, p of x is equal to g of x into q of x plus r of x. So plug in these values that you know. We know p of x, which is x cube minus 3x square, plus x plus 2 equal to g of x needs to be found into q of x will be x minus 2 plus r of x minus 2x plus 4. Now we solve this equation. So carry minus 2x plus 4 to the other side. So we get x cube minus 3x square plus x plus 2 plus 2x minus 4 equal to g of x into x minus 2. Now add the like terms over here, x and 2x and the constants. So we get x cube minus 3x square plus 3x and 2 minus 4 will be minus 2. Equal to g of x into x minus 2. So this implies that g of x will be x cube minus 3x square plus 3x minus 2 divided by x minus 2. So now we need to divide by long division method and get the g of x. I am leaving the long division for you all. The answer should be x square minus x plus 1. Write down the steps of division, long division neatly and then check your answer. Question 4. Give examples of p of x, g of x, q of x and r of x which satisfy division algorithm such that these three conditions are satisfied. So we have to give 3 set of examples. We have solved so many questions in the chapter. Now we should be able to give examples which satisfy these conditions. So let's write the polynomials for the first condition. The degree of the dividend polynomial should be equal to the degree of quotient polynomial. Now this is possible only if the divisor polynomial is a constant polynomial. So if we take p of x as 2x square plus 2x plus 8 and the divisor as 2, which is the common factor, then q of x will be x square plus x plus 4 and r of x will be 0 because 2 is a factor of p of x. So in this example, the degree of p of x and q of x is same. Second example, the degree of quotient polynomial should be equal to the degree of remainder polynomial. So let's take p of x equal to say x cube plus x square plus x plus 1. So if I write the divisor polynomial with 1 degree less than the dividend polynomial, say x square minus 1, then on dividing I get quotient polynomial as x plus 1 and the remainder polynomial as 2x plus 2. So here the degree of quotient polynomial and the remainder polynomial are same. You can check this by long division method, and by trial and error you can write more examples like this one. Let us write down an example for the third condition, that is degree of remainder polynomial should be 0. For the degree of the remainder polynomial to be 0, the remainder polynomial should be a constant polynomial. So the remainder should be just a number. So let's say if p of x is x cube minus x square plus 2x plus 3, g of x is x square plus 2, then on dividing you will get the quotient as x minus 1 and remainder as 5. Degree of constant polynomial over here is 0. Likewise, many examples can be written by trial and error that satisfy these conditions. With this, we come to the end of this video lesson and this chapter as well. Your assignment for today is as given, which is based on this section. After solving the assignment, you can check the answers for each question over here. Goodbye.